Welcome back to Arxflix. Today, we're discussing a fascinating paper titled Perceiver I/O, a general architecture for structured inputs and outputs. This work introduces a groundbreaking architecture capable of handling data from diverse settings while scaling efficiently with the size of inputs and outputs. Current machine learning architectures often require domain and task-specific tweaks, which limit their generality and scalability. Perceiver I/O tackles this by providing a unified architecture that not only processes multimodal data efficiently, but also produces structured outputs of various types and sizes. Here's an example of the diverse applications Perceiver I/O handles, ranging from language understanding to optical flow tasks, video-audio processing, and even game environments like StarCraft I. While the original Perceiver was limited to simple output spaces like classification, Perceiver I/O can decode complex structured outputs directly from its latent space. This is achieved through an output query mechanism. For instance, predicting the optical flow for a particular pixel involves composing a query from the pixel's coordinates and an optical flow task embedding. Take a look at the Perceiver I/O architecture. It maps arbitrary input arrays to arbitrary output arrays using a domain-agnostic process. This flexibility makes it computationally tractable even for very large inputs and outputs. The Perceiver I/O follows a read process approach. Inputs are encoded to a latent space, processed through multiple layers, and finally decoded to produce outputs. This method leverages the best features of transformers and encoder-decoder architectures. Transformers, although powerful, scale poorly in compute and memory due to their quadratic complexity regarding input size. Perceiver I/O's architecture, however, scales linearly and uses attention non-homogeneously by mapping inputs to a latent space, reducing compute and memory requirements significantly. Queries with output-specific features are used to produce outputs with different semantics. This design allows the Perceiver I/O to adapt effectively to various domains, making it a versatile tool for diverse tasks. The authors evaluated Perceiver I/O across several domains, including language modeling, optical flow, multimodal autoencoding, and more. In natural language tasks without tokenization, it matches or outperforms BERT, a strong transformer-based model, showing significant advantages in both performance and training time. For optical flow, a challenging computer vision task, Perceiver I/O outperforms state-of-the-art models like Raft and PUNet by directly encoding frames and querying the latent representation. The Perceiver I/O shows state-of-the-art results on the Sintel optical flow benchmark, emphasizing how well it adapts to high-dimensional data. In multimodal autoencoding tasks, such as those involving video, audio, and label data from the Kinetic 700 dataset, Perceiver I/O efficiently reconstructs these modalities simultaneously. The figure here demonstrates the quality of reconstructed videos and audio, showing impressive results even with high compression ratios. Perceiver I/O represents a significant advancement in developing general-purpose neural network architectures. Its ability to handle diverse data inputs and produce flexible outputs while maintaining computational efficiency makes it a promising tool for future AI applications. Thanks for tuning in to Arxflix. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cutting-edge AI research. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.